Hi, welcome to the first installment of the Flow Factor Conference, Getting to Know the Speakers series. Over the next few weeks before the conference starts, we will be interviewing each person presenting, whether they're doing a keynote, a session, or a workshop, to give you a chance to get to know the folks that will be there and also to help you figure out where and which topic you'd like to attend at the conference. So today, our first interview is with Matt Housley. We've known each other for many, many years, and he works for Ternary Data. Hey, Matt, how are you doing?
Doing pretty well. Great to talk to you, Chris.
Awesome. Well, it's good to have you here. So, since you're our first person, we can sort of set the stage for how these
Sure.
discussions will go. So, you get to help all the other speakers figure out what they're going to say. So, why don't we just jump in a little bit about your background, who you are, where you came from, that sort of thing, so people get to know you a little bit.
Yeah, so let's see. I started life in Washington State, and it's funny, I got into computers very young. So I programmed Logo, I did some assembly language programming way back in the day. And then when I went to college, I went to Brigham Young University in Utah, and I got into physics instead. So I sort of wandered off the path. And then I got a bachelor's in physics, then got a master's at UC Santa Barbara. And then instead of wandering back to computers, I ended up doing math. And so I got a PhD in math from the University of Utah, and I was a college professor for about 4 years. And then one of my friends asked me if I wanted to consider becoming a data scientist. And so I applied for that job, and I got the job and got into it, really enjoyed it, but I discovered that there was always a lack of engineering resources. It was really hard for us to do our jobs because we couldn't do things like host services and host models. And so I kind of wandered into that part of things and got more in the operations side of things, and then eventually decided to found this company with my partner, Joe Reese, because we saw this need happening across the industry everywhere we looked. And so kind of operationalizing the processes that underpin data science and data engineering.
Okay, awesome. Thanks for that quick background. So I guess if I have math problems, can I come and talk to you about those?
Yeah, it would be very enjoyable for me to talk about math problems. A
Okay,
nice change of pace, right?
awesome.
It's kind of a hobby now. So,
Okay, that's cool.
yeah.
I think only a mathematician would say math's a hobby, but that's okay.
Right, right. It's a sick and twisted avocation, but what can you do?
Yeah, yeah, exactly. Okay, so you mentioned that you moved from academia into data science, sort of made that
Right.
transition.
Yeah.
And you mentioned that you found that some of the engineering resources were missing, or that you didn't have what you needed to sort of get the job done. Talk to us a
Yeah.
little bit about some of the challenges that you faced in trying to implement a data engineering. Well, actually, I'm not even sure how to say the right word here. So, is it a data engineering platform or process, or why don't you give us a little bit of background on the terminologies, and then jump into some of those challenges that you faced?
Yeah. One of the tricky things here is that the term data engineering has taken on new meanings over time. And so I would say 10, 15 years ago, a data engineer was someone who stood up a database. It could be an enterprise data warehouse. They managed the schema. They granted access. It's kind of DBA plus higher level thinking about how that database should work. And in the modern realm of machine learning and data science, data engineering encompasses just a huge amount of different systems, different data types, different data paradigms. And so it's both process and platform. Process is like, what's the process for managing all these different types of data resources that exist in the cloud? How do you manage a modern data warehouse, like large-scale data warehouse like BigQuery or Snowflake? How do you manage data pipelines? How do you manage ETL processes? How do you interact efficiently with your data scientists and machine learning engineers so that they can actually do their jobs? For us, the platform also gets extremely complicated, which is why I like to focus on cloud, because I like to minimize the management overhead there. I think the term no ops is kind of BS, frankly. I don't think there's any such thing as no ops, but
Right.
I want to do minimal ops wherever possible and focus on the data processes, not necessarily managing the underlying tools.
Okay. And so when you mentioned going to the cloud and trying
Yeah,
to reduce the amount of operations involvement that you need to what,
right.
just what's required,
Yeah.
what is it that the cloud environments give you that sort of helps you adopt a data engineering program quicker?
That's a good question. So first of all, you have a much greater variety of different database types for different applications. Also, those databases can be much more ephemeral than they are on premises. So let's take the example of Hadoop. It used to be when Hadoop first came out, you would have to buy a bunch of hardware. You'd stand up Hadoop on there, so you'd install Hadoop on the individual nodes, and you would eventually load some data into it, write some pig code or some Hive code, and be able to query that data. And then, oh, there's an upgrade of Cloudera, so we got to install the new version of Cloudera, but then it breaks some of our other things we installed on a Hadoop cluster. You upgrade that. Well, in the cloud, I can just use a tool like Dataproc or EMR or Kubel, where it's just ephemeral. I just spin up the cluster I need. There's no installation because I'm just using managed images, and I can focus strictly on writing my data processing code and don't have to worry about the underlying infrastructure itself. I also have these newer type EDW systems like BigQuery or Snowflake or Redshift, fully managed databases that can handle data at extraordinary scale and make it queryable with SQL. It's much easier now for me to stitch together different systems and have them talk to each other and have data flow between them using tools like Kafka. And so for me, that means that it makes my job as a data engineer or, say, data ops much more enjoyable. It also just facilitates things that weren't really possible 10 or 15 years ago, not just because of the tool sets, but because of platform as a service and software as a service just makes it possible to move so much faster.
Okay. Just to circle back for a second, you mentioned three different big data Hadoop technologies, but you said them quickly. What were the three?
Oh, yeah. So EMR, that's Elastic MapReduce. Sorry, I'm throwing a lot of jargon out there right now, but Elastic MapReduce is kind of Amazon's default big data Hadoop stack. Dataproc is what Google offers. And then Kubel is another third-party big data stack that offers kind of a nicer management layer. One reason we like to use that. And I think there are some others as well. Those are the ones I mostly work with.
Okay.
But the idea is they give you an interface. I can spin up a cluster. I can run jobs on top of that. Yeah.
Okay. And we will put links to all this stuff at the bottom after this conversation.
Okay.
So when you talked about ephemeral, I think you were referring to the infrastructure, right? So I could stand up an EMR cluster.
Exactly.
What part is not ephemeral in that model? So I have the infrastructure running. Is the data being fed into that the part that's persistent? Or explain a little bit about bringing up the cluster and then feeding data in and getting data out. How is that part not ephemeral?
Yeah, that's a good question. So the idea is that we've moved the more durable storage of data away from Hadoop and into an object store, so like Google Cloud Storage or Amazon S3. And that way, again, I think of those as the first serverless technologies, actually. When we talk about serverless, we tend to talk about something sophisticated like Lambda, but just being able to store files without thinking about clusters or any details of that file system really simplifies the operational overhead. And so now my data is stored there, and then the processing, I just bring up as I need it. I load the data in. I'm still running MapReduce, and I still have a distributed file system in that cluster. But then when I'm done, I save it out somewhere durable and just burn it down. And so I don't have to deal with any upgrades. I can start fresh every time. And then the other part that's not durable, it's the Git aspect, right? It's all the code that you manage over time that hopefully slowly evolves and improves. And so now I can focus on the particulars of my MapReduce jobs or my Spark code and think about iteratively improving those and not about maintaining the cluster.
Okay, awesome. Yeah, and I could see how what you talked about with your jobs being stored in a Git repository sounds a lot like whether it's your Python code or your Java code, which most of us would be familiar with, or the Kotlin code. Tell me a little bit about the similarities or differences between some of the data engineering work you might do, say training or building models, and a traditional developer or microservice continuous delivery pipeline, where we make a code change and that triggers a series of operations which eventually deploys your application to production. Is there anything like that in your space when you're dealing with data engineering?
There really are a lot of parallels. And so I think over time, data engineers and ML engineers are coming to recognize the need to hang on, to keep history, to keep track of what they're doing over time, to keep different versions of models so they can roll back, or maybe they can extract certain features of an old model, or they can try to understand why something is performing poorly by looking back in time to when it's performing well. And so version control is a foundation for data science and ML engineering, just like it is for code development. One of the differences is that I think deploying code changes tends to be a fairly straightforward process, right? So identify some change I need to make. Maybe there are a couple of iterations to get it ready for full deployment. Goes through a couple of reviews, and I get something kicked back to me, hey, this isn't quite right. You need to catch this other type of error. But it's still fairly logically straightforward. Whereas if you get into the realm of models, things can get really tricky where you don't always get an improvement right away. And you have to actually do a lot of behind-the-scenes iteration before you have something that's deployable. So I think with models, sometimes it's harder to deploy just incremental small changes. But behind the scenes, your data science process should still involve incremental small changes until you get where you want to go.
Okay. And so, as you and I have talked over the years about data science versus, say, traditional software engineering, much like when I talk with .NET developers, there's a lot of words we use that are very similar, but when we dig into it, I'm like, oh, you meant something different. So when you say model, my first thought is a persistent, say, model within a Java application, which maps, columns to fields in a particular object. But I know your model is kind of different. So tell us a little bit about what you mean by model from a data science standpoint.
Yeah, and so a model is some, can I use the term model of reality? Let's call it a statistical model. It's essentially a model of a bunch of data that I've collected over time that I train in a particular way. And so in other words, my model might tell me how to respond to certain user inputs. It might tell me that if my user looks at certain pages, here's what you should show them next. And behind the scenes, it could be a linear regression model, a fairly simple statistical process run on very large amounts of data, or it could be a deep neural net. It could be a number of different types of model, but fundamentally the idea is that I feed it some simple data about my user or about the current circumstances, or it could be medical data, and then it tells me, okay, here's what you should do, or here's what you should expect. Okay. And it will return that data to me.
And so then you take those models and you actually deploy them, right, as like a service. So just like I might have a checkout service where I say, checkout, please add this item to a cart. My application can call out to your model, right? And you'll give me back. Okay. And is that usually like a REST API with JSON payloads, or what does that look like from a
increasingly? So one of the things that's happening right now, I think the big players undertook this transformation earlier. But early days of data science, models were batched. So in other words, I kind of pre-process information for a bunch of users at once, and then maybe I generate emails off of those, or maybe I kind of do something the next time they come to the site. But increasingly, ML engineers are interested in deploying real-time models, and that means that I should be able to call that model at any time and get very quick reply. And so I should, during a user session, for example, be able to call the model, feed it some data about what my user is doing, and then get a reply within maybe half a second or something like this, or maybe much less, depending on the model type. And so, increasingly, putting a model behind a REST API allows you a better real-time user experience or better responsiveness for whatever type of application you're working on.
Okay, awesome. Well, since I took us down a little bit of a tangent there, what is, just so people understand, since that is kind of the leading edge of using models, that real-time sort of response, you mentioned email might be an example of when models are used. What would you say is the most common way today that companies use a model in their process, whether it's batch or real-time? And maybe just give us a little bit of background on that.
Let's see. So I think, let's talk more about what companies are interested in doing, at least on the retail side, which I've seen a lot of. They want to do real-time recommenders. And so they want to be able to recommend things to users like, hey, you might be interested in this product based not only on your last 15 days of history, but based on the last 1 minute of history. We can see, okay, you're looking at bath towels maybe, or you're looking at sheets, or you're looking at books. What's the next book you're going to be interested in? Or what's the style that you're interested in? And so I can feed that to my real-time model and get a particular type of style back, or a particular genre of book that I can then generate additional recommendations from. And it's similar, actually. I mean, a lot of the applications of batch models are the same. And often you'll actually combine these two approaches. Like you'll have a deeper batch data mining process that can recommend a number of items to the user. that you would then send them in an email or show in their next web session. And then you have this real-time process that's just meant to extract from what they're doing right now, or maybe they have some very specific intention or they're looking for a specific product.
Okay, awesome. Yeah, definitely an exciting space, and obviously that's
Yeah.
where so many companies are putting time and attention. So thanks for
Yeah.
the background. Okay, let's shift our focus a little bit to your talk at Flow
Yeah.
Factor Conference this year on June 11th at Embassy
Yeah.
Suites in South Jordan.
Yeah.
So why don't you tell us about your talk, its title, a little bit of background.
Yeah, so I'm going to be talking quite a bit about data agility and data pipeline agility. And the fundamental idea here is that we're building out all these systems in the cloud, right? And you get an extraordinary amount of complexity. And how do we manage that complexity? It's the same kind of conundrum that eventually arose in the realm of software development. You develop these really complex systems. How do you keep them moving forward? How do you avoid stagnation? And so to do that, you need systems that manage data pipelines. And again, going back to the cloud discussion of the difference between on-prem and the cloud. In the cloud, you can encompass many more systems than you get on-prem. And so you need to stitch all these together. And so I'll be talking about tools like Apache Airflow and AWS Glue that allow you to connect systems together and manage those data flows. And that allows me to do things like go to my data scientist, say, what data changes do you need today? And then deploy a new pipeline almost immediately that will start delivering data to them so they're no longer having to manually munch through that data and try to find what they're looking for. If they have a new idea for a way to process the data, then I can deliver that to them very quickly using this whole palette of cloud tools, but I have to have an overlying manager to take care of that. And so the analogy for me is that a tool like Airflow in the data engineering, data pipeline space is very analogous to a tool like Jenkins in the code space, where it allows me to manage and deploy changes in data pipelines very quickly. Those small changes in data then become the foundation of improvements in machine learning and data science and experimentation.
Awesome. So based on the folks coming to our conference, we're going to have everyone from management and executives to developers, data scientists, operations, project managers, QA, sort of the whole project life cycle. I like to say the people that take an idea and bring it to production, everybody involved.
Right.
Who would you recommend attend your talk at the conference?
I think it's the whole spectrum. I think it's anyone who's interested in data processes, and this could be at the product manager level. It could be at the director level. If they want to understand ways to improve data processes, I want to spend at least half of this talk on kind of a high-level view of why these tools are important. And I won't promise that I'm not going to get into any of the technical details, so maybe their eyes will glaze over for the last 20 or 30 minutes. But hopefully they'll come away with something where they have some ideas for processes that they can implement that will accelerate their data science and machine learning improvements and iteration.
Okay, awesome. And then take a minute and tell us about your company. And I think you and maybe some other folks from your company will be at the conference. So tell us a little bit about what you guys are doing.
Yeah, so Joe Reese and I, the two co-founders, will be speaking. Our company is Ternary Data. We're fairly new at this point, but we started talking a little over a year ago and discovered that we were seeing the same problems all over the place in the industry. That is, companies would hire a lot of data scientists and then had trouble with the underlying processes and infrastructure to enable those data scientists. So building data infrastructure, having data operations, creating appropriate data architecture. And so we founded the company to address those needs, building out appropriate databases, building out data processes and data agility so that data scientists can realize their potential and companies can start seeing value in their data.
Okay. Well, thanks so much for your time today, Matt. I appreciate you giving us some background on data engineering, on your company, on what your talk is going to be. And for all of those who've listened to this part or got this far in our interview, we wanted to throw out a little special thing for everybody, a little Easter egg, if you will. And so when you come to the conference and you see Matt, Matt has put together a little question for you to ask him. And when he hears you ask the question, he'll know that you got to the end of the interview. So Matt, what is your question?
How is your data working for you? And actually, this is a question that I'll want to ask you if you come up and talk to me at the conference, but you can ask me first and then we can talk about it. So this is frequently data just sits in warehouses and doesn't get utilized and doesn't get leveraged. And so our goal is to find ways to get the value out of the data that's already there.
Okay. Awesome. Well, thanks so much for your time. Can't wait to see you on June 11th and to get the show rolling. And have a great night. Thanks.
Thank you.